write a function, tic-tac-toe, that allows two players to play a game of tic-tac-toe. So here, our two players are X and O, and X will start first. And next, the first player to get 3 in a row wins. A move is invalid if the player attempts to enter anything other than 1 to 9, or if a piece already exists on that spot. So if a move is an invalid move, prompt the player to try again. So here, using this as an example, this is our starting board. And here, X will start first. And after he enters 5, notice that 5 is replaced with X. So after X turn will be O's turn. And in this case, O enters 2, and O will be here. Afterwards, once again, is X turn. So X enters 3, and so X will be at 3. And next is going to be O's turn. But if O enters 3, this is an invalid move because O cannot override X. And hence, invalid move will print, and O will be prompted to try again. So in this case, O enters 1, and O will replace 1. X enters 7, and 7 will be replaced with X. And here we have 3 in a row. And in this case, X will win. So do pause this video and take some time to give this a go before taking a look at the answer. So while this function might seem pretty complicated, let's actually break this down into mini steps. So here, let's define tic-tac-toe, open and close bracket, and here we start writing our function body. So here, the first step is to allow our user to choose their move. So here, we can do this using a while loop. So while true, and we have input over here. So here we have choice is equals to input, and let's print choice. So next, let's call tic-tac-toe, and let's run our function. So if I enter A, B, C, D, E, I'll print A, B, C, D, E. If I enter 1, 2, 3, I'm gonna print 1, 2, 3. Next, let's set our current user. So current is equals to X because X start first. So here, I'm gonna turn this into a F string, and I'm gonna add current apostrophe S turn. And here, if I run this, I'm gonna get X turn. So let's say I enter 1, and I'm gonna print 1. And next is still gonna be X turn, which is not very correct. If current is equals to X, current is equals to O. And here else, current is equals to X. So here, we'll switch between X and O for now. So let's run this. So X turn, let's say 1, and O's turn will be 2. And afterwards, we are going to have X turn again. So here, whatever I enter, notice that X and O will keep switching. So here, our first step is done. And next, we need to define our board. So here, I'm just going to create board is equals to list. So my list is going to have 3 rows. And here we are going to have 1, 2, 3, 4, 5, 6, and 7, 8, 9. And before we ask for the user's input, let's print board. So here, notice that my board is printed in this manner, which isn't very optimal. So instead, let's write another function that will display board for us. So I'm going to define display, and I'm going to have board. So for row in board, I'm going to print, and here, this star here will unpack everything inside the row. So here, instead of printing, I'm going to display board. And if I run this, I'm going to have this output here. However, we also need to print the lines. So set is equals to vertical line at a space here and a space here. So let's rerun this, and here we have it. And after our for loop, we simply print. So here, when we print our board, we simply use the display function, and it's going to print our board in this manner. So at this point, if I select 1, nothing will happen. And if player O selects 2, nothing will still happen. So next, before we replace any of this with X and O, we need to check that our move is actually valid. So let's define move is valid. And it's going to take in move and board. Move needs to be 1 to 9. And also, the target must be empty. So here, if move not in list 1, 2, 3, 4, 5, 6, 7, 8, 9, we print invalid move. Move must be a number. And then we return false. So here, this if block will check whether the player enters a number from 1 to 9. And next, I'm going to print string of board. So here, I'm going to call move is valid. And I'm going to pass in move and board. So move and board. So here, this is going to be choice. And if I run this, I'm going to get my normal board. And let's say I enter A, B, C, D, E, F, G, which is an invalid move. So if I enter this, I'm going to get invalid move. Move must be a number. Next, let's rerun this once again. And if I enter 1, I'm going to print string of board. So here, string of board will simply be board converted to a string. So for 1 to be valid, 1 must be inside the string. For the move 2 to be valid, 2 must be inside the string. So here, I can use this to check if this is an invalid move. So if move not in board, I'm going to print invalid move. This spot is already taken. And after this, I return false. And at the end of the function, I return true, which means that if I reach this line, the move must be valid. Since this returns a Boolean value, I'm going to put this in a if block. So if move is valid and else. So I'm going to remove choice. And next, we have to decide what to do if move is valid and what to do if move is not valid. So if move is valid, we will add move into board. And afterwards, we will switch X and O. We will check if anyone wins. However, if move is not valid, we do not switch X and O. So here, we prompt user to try again. So in this case, this code which switches X and O will be moved here. And here, we simply prompt invalid move. So here, let's say X is 1. So this is a valid move. So this will change. However, if I enter A, B, C, D, E, F, G, this is an invalid move. So invalid move must be a number. It's an invalid move. So if I enter some invalid move, it will always be O's turn. And afterwards, let's figure out how to add our move into board. So let's call this define add move to board. And here we have player, we have move, and we have board. So here, let's say the player X enters 1. So on our board, we need to replace 1 with X. So here for I row in enumerate board, and for J value in enumerate board I, if string of value is equals to string of move, we replace the value in board itself. So ij is equals to player. So here, add move to board, we have player, which is current, and we have move, which is choice, and we have board. And here, let's say I enter 5. And next, notice that 5 will be replaced with X. And next, if I enter 3 for O, notice that 3 will be replaced with O. And let's say if I enter 3 for X again, this will be an invalid move. And notice that it will still be X turn. So now X can choose to put, let's say 1. And here notice that X will replace 1. So let's say O enters 6 and X enters 9. So here, notice that X has already won because it has 3 X's in a row. However, our code is not able to do that yet. So next, we have to check for the winner. And here, let's define check winner board. So here in tic-tac-toe, there are only 8 ways to win. So we can do it horizontally. So we have 1, 2, 3, 4, 5, 6, or 7, 8, 9. Or we can do it vertically. So let's say 1, 4, 7, 2, 5, 8, or 3, 6, 9. Or we can do it diagonally. And in the case of diagonally, we only have 2 possibilities. We have 1, 5, 9, and 3, 5, 7. So here in our check winner function, we can check for this 8. So here, I'm going to define combinations is equals to a list. So this will contain all of the winning combinations. So let's do 1, 2, 3 first. So 0, 0, which is 1. And afterwards, we are going to have 0, 1, which is for the number 2. And next, we are going to have 0, 2. Here, this is going to be the row number, and this is going to be the column number. So at row 0 and column 0, we are going to have 1. And at row 0 and row 1, we are going to have 2. And at row 0 and column 2, we are going to have 3. So next, let's add the second row. So the second row is going to be 1, 0. So here, at row 1, which is this row, and column 0, which is this, we are going to get 4. So this is going to be 1, 1, and this is going to be 1, 2. And similarly, let's do the same for the third row. So this is going to be 2, 0, this is going to be 2, 1, and this is going to be 2, 2. And let's do the same for our vertical win combinations. So here, we want to have 1, 4, 7. So this is going to be 0, 0. And this is going to be 1, 0. And this is going to be 2, 0. And next, we want to get a column 2, 5, and 8. So 2 is going to be at 0, 1. 5 is going to be at 1, 1. And 8 is going to be at 2, 1. And next, let's deal with 3, 6, 9. So 3 is going to be at 0, 2. 6 is going to be at 1, 2. And 9 is going to be at 2, 2. So here, we also need to take care of the diagonals. So 0, 0, which is 1. 5 is going to be 1, 1. And 9 is going to be 2, 2. And next, let's take care of 3, 5, 7. So 3 is going to be at 2, 0. 5 is going to be at 1, 1. And 7 is going to be at 0, 2. So here, these 8 are all the winning combinations. So for combination in combinations. And next, we are going to print combinations. And next, I'm going to create a board. So let's say board is X, X, X. And here we are just going to have 4, 5, 6 and 7, 8, 9. So here, if we call our check winner, so we should print all combinations for now. Let's actually get the values out of our board. For row column in combination, value is equals to board row column. And here we have string is equals to empty string. And let's just simply add this to string. So string plus equals to string board row and column. And let's print string. So if we run this check winner function for our current board right now, we are going to get this output. So we're going to have xxx 4, 5, 6, 7, 8, 9, x 4, 7 vertically. We have x 5, 8 vertically and x 8, 9 vertically. So here, notice that our first row is a winner. So as long as we have one winning combination, we know that x has already won. So next, we just need to check whether all characters in this string are the same. So if string 0 is equals to string 1 and string 1 is equals to string 2, we return string 0. So here, if x is a winner, we return x. But if O is the winner, we return O. And at the end of our function, if we manage to reach here, we simply return false. If I run this, I'm going to get x. So after our for loop, we simply return none. So if we look through all our winning combinations and none of them have a winner, we know for sure that there is no winner yet. So at this point, we simply return none. And if we run it for XOX, we are going to get none. However, if I replace this with an O, and if I replace this also with an O, I'm gonna get winner is O. Let's say if I replace this with an X, now there's no winner, so there's gonna be none. And if I replace this with an X again, there's a winner now, and I'm gonna get X. So here we have successfully written our check winner function, and let's use it. So here, winner is equals to check winner board, and if winner is not none, we return winner, and before this we print winner wins. And here let's remove this testing code and let's run tic-tac-toe. So here, let's say I put at 5. Notice that 5 is going to be replaced by X. And next, let's say SO I want to put at 3. So 3 is going to be replaced by O. And next, I'm going to put at 2. So here 2 will be replaced by X. And next, let's say O is stupid and O puts 9. So here 9 is going to be replaced by O. And here if I put 8, X wins. However, notice that we do not print this out. So let's actually do that. So once again, so let's say I put at 5, and next I'm going to put at 3, then 2, 9, and 8. So here, X has 3 in a row vertically, and X wins. So next, let's run this and make O win. So let's say 5, 2, 4, 3, 8, and 1. So in this case, O wins because O has this vertical line over here. And so here we have successfully written our tic-tac-toe function. So once again, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.